question number one, it's asking about a reflection over the line y equals x. The line y equals x is a slanted line that has a y-intercept of 0 and a slope of 1. So it could be a little bit hard to reflect over this line because let's say this is my point 2, 3. Let's say this is my point 4, 7. And let's say this is negative 1, 5. It could be a little bit hard to reflect over this line because we have to count diagonal spaces. So there is a rule for reflecting over the line y equals x, which I think is a really helpful rule. And that rule is that you take, let me just write down the rule here. That rule is that you take the original coordinate and you just switch the order of the coordinates. So that is going to be, this first one's going to become 3, 2. So I'm going to put that here, 3, 2. The second one's going to become 7, 4. And the third one's going to become 5, negative 1. So the only one that's here is the answer choice 5, negative 1. In number 2, we're asking which figure will not carry onto itself after a 120-degree rotation about its center. So let's try them out one by one. So equilateral triangles, so that has a total of 3 sides. So if I do 360 degrees divided by the 3 sides, I do get 120. So the minimum rotation that will carry the equilateral triangle onto itself is 120 degrees. For the octagon, that is an 8-sided figure. So if I do 360 divided by 8, the minimum rotation that will carry it onto itself is 45. So the question is 45 a multiple of 120? 2 45s is 90. 3 45s is 135. So no, this is the answer choice we're looking for. 120 is not a multiple of 45. But let's just check out the other ones. If we did 360 divided by 6, that's 60 degrees, which 120 degrees is a multiple of. And the nonagon is a 9-sided figure, which is 40 degrees if we divide. And that is a multiple, 120 is a multiple of 40 as well. Okay, moving on to number 3. So remember, we're looking for either a point in the center if we're rotating it around to carry it onto itself, or we're looking for a line of symmetry to reflect it over so that it looks like itself. So let's check out the first one. The first one is a 180-degree rotation counterclockwise about the origin. Well, that doesn't look like it's going to work. I don't think that's going to carry it onto itself because that's not in the center. If it was here, then yes. So that's not the answer choice we're looking for. Now, answer choice number 2. So the line y equals 1/2 x plus 1 has a y-intercept of 1. So that's where we start graphing. And the slope, 1/2, tells us to move up 1 and over 2. Up 1, over 2, and I'm going to get in the other direction. Down 1 and left 2. Ooh, that does appear to be a line of symmetry. Let's just look at the other choices so that we can verify that this is the one that we're looking for. The line y equals 0, so that's where all the y coordinates are 0, so be careful. That is the x-axis because the x-axis is where all the y coordinates are 0. And notice how that blue line is not a line of symmetry of the figure. And the line x equals 0 is where all the x coordinates are 0. So that is the y-axis. As along the y-axis, all of the x coordinates are 0. So now we have to ask ourselves, which is the correct answer choice? Is it 2 or is it 4? And the answer is answer choice 4, because answer choice 4 is actually a line of symmetry. And the reason for that is it goes from a corner to a corner, whereas the original answer choice 2 that we had did not. And if I get rid of answer choice 2 here, it'll make it a little bit more clear for you guys to see. And here we see that the y-axis actually is a line of symmetry. If we reflect over, it will look the same as itself because it's cutting it into two symmetrical pieces. Okay, let's take a look at the next one. It's asking for the center of dilation after a dilation by a scale factor of 1/3. So notice how triangle ABC is the pre-image and triangle DEF is the image after the dilation happened. So it got smaller with the dilation of 1/3. So the important thing to keep in mind is that when you have a dilation, if it's getting bigger, the points are moving away from the center of dilation. But if it's getting smaller, the points are moving towards the center of dilation. So I know that the center of dilation has to be somewhere over here because it's got to be closer to the image than the pre-image. So it's got to be somewhere over here because the image moves closer to the center of dilation. So it's somewhere here. Also, what I know is that since this is a third of this, I know that the distance that these points are from the center of dilation has to be a third of the distance that these points are from the center of dilation. Another way of saying that is that these points are 3 times away from the center of dilation as the points in this triangle are. So I need to find a point, for example, where B is 3 times the distance from the center as E is. The first answer choice is 0, 0. That can't be correct because it should be further than the image points, because the pre-image is further from the center, the image is closer to the center, but the center should be somewhere over here. So that's not it. Let's check out the next answer choice. 1, 2, -1, -2, -3. That might be it. Let's count distances. So I'm going to compare B to E because B matches up to E. B is the pre-image and E is the image. So 1, 2, 3 up and 1 over. So if that's 3 up and 1 over, if this is the center, then I should expect the distance to be 3 times 3 is 9, and 1 times 3, so I wrote 3, 3 times 3 is 9, and 1 times 3 is 3. So I should expect it to be 9 up and 3 over from the center. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. That is it. That is 3 times the distance from the center of dilation as the image. So the pre-image is a third of the distance from the center. If you check out the other two answer choices, and I'll just check them out really quick. If you check out the other two answer choices, 0, -2, that can't be it, because if that was the center of dilation, then the original figure would have been here as well. Because if it's the center of dilation, it doesn't move. So if it's part of the shape, it would stay in the same spot. So that can't be it. That's definitely not it. And the next one is -4, 0. So this one can't be it for the same reason as we said before. Because when you dilate by a scale factor that is between 0 and 1, the pre-image is further from the center as the image. The image moves closer to the center of dilation if you're making it smaller. So the center of dilation has to be somewhere over here. So that can't be true. So answer choice 2 is the only answer choice that even could have been it. That even graphically made sense anyway. In number 5, we have that AB is parallel to DC. And we have trapezoids here. And we're rotating trapezoid A prime, B prime, C prime, D prime. The rotation was 110 degrees counterclockwise from here to here about point P. And it's asking which statement is always true. Usually these questions are just asking about the property of the transformation. And since a rotation occurred, we're probably going to have a question about the properties of rotations. So keep in mind, rotations are rigid motions. That means they produce congruent figures before and after. Remember, congruent figures have equal sides and equal angles, and that's probably all we need to know. So answer choice 1, angle A congruent to angle D prime. Well, do angle A and angle D prime match up? No, angle A and angle A prime match up. Angle D and angle D prime match up. Those are not corresponding angles. Those are not going to be congruent after the rotation. AC is congruent to B prime D prime. Does AC match up to B prime D prime? No, AC matches up to A prime C prime. BD matches up to B prime D prime. So no, they're not corresponding sides, so they're not going to be congruent on the congruent figures. Answer choice 3. A prime B prime is parallel to D prime C prime. Well, yeah, because originally A, B, and DC were parallel. So they're actually still going to be parallel because a rotation produces congruent figures and it keeps lines parallel to each other because it doesn't change the figure in any way. All it does is turn it, so it has a different orientation, but nothing else is altered. So that's the correct answer choice. That's always true. Finally, answer choice 4. No, we have no reason to know that B prime A prime is congruent to C prime D prime. In fact, since we know that this is a trapezoid, that would definitely not be true because bases of a trapezoid are never congruent. Legs of a trapezoid might be congruent if it's isosceles, but bases are never congruent. They're clearly different sizes. Moving on to number 6, it's asking which sequence of transformations maps triangle ABC onto triangle DEF. So what we have to be careful of here is the orientation. We have to make sure that they're going to be facing in the same direction after each of the transformations occur. So the first one says a counterclockwise rotation, and we're going from ABC to DEF. That's important too. A counterclockwise rotation. So here's my clock. Okay, so you can get the idea. So we're going this way. So it's going to move to this quadrant of 90 degrees about the origin, followed by a reflection over the y-axis. So I'm going to actually do it. So 90 degrees about the origin. Here's the origin. 1, 2, 1, 2, 1, 2, 1, 2. There's B prime. 1, 2, 3, 4, 5, 6. 1, 2. One, two, three, four, five. 1, 2. Okay. So let's check out the orientation. So based on the naming here, A and D are ultimately going to have to match up. B and E are going to have to match up, and C and F are going to have to match up. But wait, there's more than the 90-degree counterclockwise rotation. Then there is a translation of 8 units to the right. So a translation is just going to slide it. So it will slide it over here to the same spot, but A prime is going to be here, B prime is going to be here, and C prime is going to be here. A and D do match up. B and E do match up. C and F do match up. So far, this is seeming to be a fine choice. So I'm going to put this one on hold and put a star here because this might be the correct answer. Number 2. Oh, I shouldn't have erased that because it's the same rotation. The only difference is after the counterclockwise 90-degree rotation, this one has a reflection over the y-axis. So if I reflect over the y-axis, 1, 2, 3, 4, 1, 2, 3, 4. Oh, I miscounted. My bad. 1, 2, 3, 5, 6. So this is going to be A prime. That's going to be B prime. And that's going to be C prime. But B and E have to match up, not B and D. And A and D have to match up, not A and E. And C and F have to match up. That's the only one that does here. The orientation's not correct because it was already the correct orientation, and then it flipped and the orientation was no longer correct. So that's not the correct answer choice here. Make sure that those letters match up the way that they need to. The next one is the same rotation, followed by a translation of 4 units down. 4 units down would put it over here. No, we need to slide it over, so that's definitely not correct. And the next one is a clockwise rotation. So a clockwise rotation followed by a reflection over the x-axis. So, I mean, I don't know until I try it, so I'm going to try it. A clockwise rotation is going to be in the other direction, so let's do it here. And this one is ending up being a little bit time-consuming. So here's the origin. And clockwise is this way in the direction that the numbers move. One, two, three, four, five, six. 1, 2. 5 and 2. Sorry, it's a bit messy here. The only thing that really is important is the orientation. So that's after the rotation of 90 degrees clockwise. And then if we're reflecting it over the x-axis, we're going to flip it over the x-axis. To reflect over the x-axis, let me just outline the x-axis. Here it is. We're going to count the spaces and move an equal number of spaces to the other side. So A prime is here. So it's 1, 2 spaces. So it's going to go here to where E is. But already that's not good because A needs to match up to D, not to E. So already that's not even going to be the correct orientation. So our correct answer choice was the answer choice that we saw before. Let me scroll back down to it. And our correct answer choice was answer choice number 1. I'm going to put it back on here. And here is the correct answer choice back. That is answer choice number 1. For number 7, the first thing we need to do is we need to take the equation of the line and we need to put it into y equals mx plus b form. So I'm going to subtract 6x from both sides. And now I'm going to divide everything by 3. And now it says I'm dilating this line centered at the origin by a scale factor of 2. So remember, before and after the dilation, the slopes are going to be the same because dilations preserve parallelism. We're going to take the y-intercept and we're going to multiply it by the scale factor because our center of dilation is the origin. Now remember, if the center of dilation was on the line instead, then it would result in the same line because all the points would shift along the line. Once again, that's if the center of dilation was on the line. Here, the center of dilation, the origin is not on the line. Because if you take the point 0, 0 and you plug it into the equation, 0 plus 0 is 0. 0 is not equal to 3, so it's a false statement. So the 0.00 is not on this line. The next one's a bit tricky because we need to describe the transformation as specifically as we possibly can. But the problem is that we don't have a grid. We don't have numbers, so we can't see exact measurements here. So all that we can do is use what's in the given information here to describe our transformation. And what we know is that AB is congruent to DE, so AB and DE are going to have to match up. AC is congruent to DF, so AC and DF are going to have to match up. Let me be marking this. And A is congruent to angle D, so angle A and angle D are going to have to match up to each other. So also the letters tell us what the orientation needs to be, because A needs to match up to D, as we already know from the givens. B needs to match up to E, and C needs to match up to F. So we might be thinking that a rotation is necessary here. And the rotation needs to have a direction, and it also needs to have a center of rotation, and usually the number of degrees, which I don't think we're really going to be able to specify here, but we'll try. So for our center of rotation, let's do point C. And we can imagine that the whole triangle is rotating around point C. And we want to rotate it so that A falls over here where D is. And so AC matches up with DF. And so that AB matches up with DE. As you can see here, a translation will still be necessary. Now, I don't know the specific amount of units that we're going to need to translate, but I know that we're going to need to rotate, we're going to translate up so that this matches onto this, and so this matches onto this. So let's try our best to describe this. So I'm going to put first a rotation centered at point C. And what direction is this? That's clockwise. So a clockwise rotation centered at point C. And I'm trying to think of a good way to describe how we're going to rotate it, because as I said before, we don't have a degree measurement because it's not actually on a grid. So we don't know like actually what the angle is that it's rotating at. But we do know that we're rotating it until AC is parallel to DF, until they're lined up, and then stop. Because if we kept rotating it more, then it wouldn't match up anymore. So we want to rotate until these two line up, until they're parallel to each other. So I'm going to put here until DF is parallel to AC. Then a translation so that side AB matches up to side DE, side AC matches up to DF, and angle A matches up to angle D. And that's the best way I can describe this transformation. We do try to be as specific as possible, but when we don't have a grid, when we don't have numbers, the only thing that we have to use are the components given to us in the problem. In the next question, it will be a little bit easier to describe the sequence of transformations more specifically, due to the fact that we have a grid here and we have actual coordinates and we have actual points. So we can actually see, what the angle is of rotation, if a rotation is here, or what the line of reflection is. If a reflection occurred, we can actually see. So let's check it out here and let's see. we're mapping rock onto R prime, O prime, C prime, K prime. So the orientation definitely changed. So if we flip it, let's say we were to flip it over this line. If we were to flip it, K would match up here, O would match up here, but C would match up here and R would match up here. So it's not a reflection over that line, at least not a reflection by itself. So let's see what else it could be. If we think about it rotating 180 degrees, that might do it, but let's check out and see if the points actually map on. So I'm thinking centered at the origin so that it moves around the grid. So let's check this out. So that's 1 up and 1 over. So that's where I have K prime. Let's check out C. 1 up, 1, 2, 3 over. Let's check out R. 1 over, 1, 2, 3, 4 up. And finally, O prime. 1, 2, 3, 4. 1, 2, 3. 4 over and 3 up. And this is a little messy here because I have like a marker on here, not like a pencil. But as you can see, it doesn't exactly match up. So this is also going to require a translation as well. And it looks like the translation is going to be up 1 unit, left 2 units. So let's describe this sequence of transformations. So this would be, based on what we said, a rotation centered at the origin of 180 degrees counterclockwise, followed by a translation of 2 units to the left and 1 up. This is not the only series of transformations that would accomplish this goal, but this is one. To construct the line of reflection, we're going to connect 2 pairs of corresponding pre-image and image points together. And then we're going to grab our compass. Let me bring it down. And what we're going to do is we're going to make a perpendicular bisector so we can have equidistant from the pre-image and the image points. So it doesn't matter which exact distance you use, just 3/4 of the way down. Arc above, arc below. Move over to the other endpoints. And without changing the distance of the compass, make the same arc above and below. And through here, we make our perpendicular bisector.
To be even more accurate, we should do the perpendicular bisector of this line segment as well, and it should be the same line. Over here in number 11, we are dilating by a scale factor of 2 centered at point D. So remember what we're doing when we dilate by a scale factor that's greater than 1 is we're increasing the distance that the point is away from the center of dilation. So if the center of dilation is D, I'm going to count how many spaces. For example, point C is from point D. 1, 2, 3. 1, 2, 3. So 3 over and 3 down. And now I'm going to double this distance away from the center. 1, 2, 3. 1, 2, 3. And that's where point C prime should go. 1, 2, 3, 1 to get to point B. 1, 2, 3, 1. We're increasing the distance that it is away from the center of dilation. 1, 2, 3, and 1 down. 1, 2, 3, and 1 down. Notice how the new dilated figure is 2 times as big as the original. It was dilated by a scale factor of 2 by moving each of the image points 2 times the distance away from the center of dilation as the pre-image points were.